2 a.m. on a remote airstrip in Saskatchewan. A journey of discovery is about to begin. Scientists working for Canada's Atmospheric Environment Service will try to send a 10-story high balloon up to the ozone layer, 35 kilometers above their heads. Timing is critical. The balloon must complete its mission before sunrise for the data to be of maximum use. With a half an hour to go, the balloon is ready for launch, but the payload isn't. A wire has broken off a key piece of equipment. As the minutes tick by, they carefully solder it back together. At last, everything is ready. The exploration of the atmosphere enters its latest phase. The ozone layer is one of the upper layers of atmosphere that surround and sustain our planet. It lies above the clouds and acts as a filter, blocking the sun's ultraviolet radiation from reaching the Earth's surface. The relative calm of the ozone layer is in marked contrast to the violence of the atmosphere that lies below it. Here, vast forces interact to form our weather. The sun provides the energy that drives the system, warming our planet continuously and unevenly. Heated moist air rises from the surface to form clouds. Large air masses of different temperatures mix together and create winds, which carry the clouds around the globe. Eventually, the moisture returns to Earth as a blizzard in Toronto or a hurricane in the Caribbean. Predicting the weather can protect us from its worst consequences, but it depends on understanding how the atmosphere works. In Canada, meteorologists have been building that understanding for more than 100 years. During the terrible storms of 1868 and 69, over 300 ships went down in Canadian waters. These tragic losses gave birth to our weather service. It provided storm warnings along Canada's eastern seaboard and the Great Lakes, but to be effective, they needed day-to-day weather observations. Lighthouse keepers were some of the earliest weather watchers. They lived where foul weather hit hardest. Although they were not meteorologists, their weather-dominated lives gave them insights that many other people lacked. The government issued them with wooden boxes called Stevenson screens, still used today to protect weather instruments. Day by day, they recorded the basic ingredients of weather: temperature, air pressure, wind, and humidity. It was a small but necessary beginning. The information from these field stations was relayed to the Central Weather Forecasting Centre in Toronto and into the waiting hands of the forecaster. His main tool was the weather map. This is where the mass of information finally came together into a coherent picture of the atmosphere, high and low pressure areas moving over his forecast region. Improvements in forecasting went hand in hand with advances in technology, like the invention of telegraph. This speeded up the flow of information. As fast as data came in from his far-flung stations, the forecaster incorporated it into his analysis. He also had to be in tune with the weather. He used the maps as a starting point and then added his own experience to formulate the forecast. Gradually, the understanding of the atmosphere was building. Forecasting in Canada was evolving into a science, but it was limited by the small area it was able to monitor. In the early days, stations and forecasts only covered central and eastern Canada, where the vast majority of the population was concentrated. They needed information about the weather in Western Canada to get a broader picture of what was happening. With the western expansion of the railway and its accompanying telegraph network, weather stations spread across the country. But the puzzle was far from complete. Forecasters had a pretty good picture of events on the ground, but they needed to find out what was happening far above them. At the turn of the century, they found a way of getting there. They tied weather instruments to balloons and sent them up to take readings. While their knowledge of the atmosphere improved, the forecasting service was hampered by another problem. People whose lives depended on the weather needed to know the forecast soon after it was issued. Post offices and newspapers were used initially, but the forecast was often out of date by the time the people in the country had a chance to read it. In the 1920s, this problem was solved with the invention of radio.
And now for the weather. There has been an unusual amount of rain lately, and it shows no sign of letting up. Thunder showers are expected again tonight, ending sometime in the early morning. Tomorrow's weather calls for cloudy conditions, with a good chance of showers late in the day. Due to heavy rainfall over the past 2 weeks, rivers are raging, and low-lying areas may once more experience severe flooding. Residents are warned to be on the lookout for high water.
Surviving a storm on the ground can be difficult enough, but another 20th century invention put people even more at risk. In the age of flight, more effort began to go into forecasting. New weather stations were added at airports to provide up-to-date flight information, and pilots were added to the growing crowd of weather watchers, relaying back observations on conditions up there in the clouds. In World War II, the number of planes increased dramatically, and weather became an important part of battle planning. The Canadian Weather Service expanded to 10 times its pre-war size. They provided weather training and pre-flight briefings to more than 100,000 aircrew who trained in Canada, information that could mean the difference between life and death. After the war, the Weather Service began to expand its research into the harshest region of Canada, the Arctic. It was a difficult place to gather data, but it was an important gap in the forecasting picture because all of Canada's cold air masses form in the Arctic before moving south. There were now very few places on the planet where the atmosphere had not been studied. Balloons had even managed to rise into the ozone layer, going as high as 40 kilometers. But that was their upper limit. There was still a vast amount of thinly dispersed atmosphere above that, which required more sophisticated technology before it could be studied.
6, 5, 4, 3, 2, 1, fire.
Black Brant rockets, developed in Canada, were launched from Churchill, Manitoba, bringing the entire atmosphere within reach. Today's forecasting is a triumph of global cooperation. A dozen weather satellites orbiting above our atmosphere give us continuous views of conditions below. Close to 500 ship-based stations sail the seas, and over 10,000 ground-based stations ring the planet, some of them in remote locations like Sable Island, 130 kilometers off the coast of Nova Scotia. Sable is best known for its wild horses, but it also has one of Canada's oldest weather stations. Meteorologists are the only permanent residents of this storm-ridden island. They usually do a 2-year stint before moving on to their next posting. Sable Island is one of over 400 observing stations in Canada. Meteorologists record the same kinds of measurements their predecessors did, plus quite a few others. Every hour, Sable's information is sent to the central forecasting offices on the mainland, where the complex process of preparing a forecast takes place. Radar is used to scan the skies for rain and snow. Dishes on the ground receive a constant stream of information from orbiting satellites. Supercomputers based in Montreal convert the mass of incoming data into weather predictions using mathematical models. But machines can't do everything. People are still a crucial part of forecasting even today. Computer models do well on the 3 to 5 day forecasts, but the daily short-term predictions need the forecaster's experience. They fine-tune the local forecast using their own expertise.
Very little in terms of weather and frontal thunderstorms going through.
Only hours after measurements were taken at field stations around the country, the forecast is issued and incorporated into everyday life.
Southern Ontario, Windsor is sunny and 23, Sarnia sunny and 21.
This is Toronto International Airport, information Delta. Toronto weather 6,000 scattered, 14,000 scattered, visibility 25 miles. Temperature 60.12. Wind is from Toronto altimeter 290.490.
Today's weather forecast is more reliable than it's ever been, and it's getting better. After more than a century of study, we're starting to understand how the atmosphere works. But the science that had its beginnings in warning us against foul weather is now telling us of a much worse kind of storm that is brewing high above. The ozone layer, our protective screen, is in serious trouble.
Liftoff. We have liftoff. The tower is cleared. And we have a roll program.
In 1984, the Space Shuttle carried an instrument into space as part of a Canadian experiment to study the ozone layer.
And we have a second program.
Marc Garneau, the first Canadian in space, pointed a device called a sun photometer at the atmosphere below him to determine how much ozone was there. The ozone layer came to world attention in the 1980s at the extreme south of our planet, the continent of Antarctica. British scientists found a massive ozone hole, thousands of kilometers across, a vast region where the sun's ultraviolet rays were no longer being filtered. Data from satellites orbiting the Earth was checked to see if the ground results from Antarctica were true. They confirmed that the Antarctic ozone hole did exist. Scientists also discovered that the ozone layer was thinning around the entire globe. The main culprit was chlorine from chemicals called chlorofluorocarbons, or CFCs. Once widely used as propellants in spray cans, CFCs are now used to make styrofoam and to clean computer chips. They're also the main cooling agents in refrigerators and air conditioners. Contained on the Earth's surface, they're harmless, but when they leak from their containers, they slowly rise up through the atmosphere until they reach the ozone layer. Interacting with the sun's powerful ultraviolet rays, they finally break apart, releasing chlorine, which goes on to destroy ozone molecules. This discovery has prompted a flurry of urgent experiments, like the balloon releases in Saskatchewan. It's now 5 a.m. at the release site, and the ground crew is still monitoring signals from the ozone balloon. It's been floating at 35 kilometers for the past 2 hours, transmitting data on the concentration of chemicals that can affect ozone. As the sun's rays strike the ozone layer, instruments on the ground receive the last bit of information from the balloon. Released from its floating membrane, the payload glides back to Earth, where it'll be overhauled and prepared for another flight. The Saskatchewan releases are part of a Canadian project called Stratoprobe, designed to monitor the chemistry of the ozone layer. Tests are also being conducted at sites further north. In the midst of the harsh Arctic winter, scientists have been probing for signs of ozone depletion. The Canadian experiments have confirmed that the ozone layer over Canada is thinning. At York University in Toronto, satellite imagery shows the greatest ozone thinning as a dark blue patch on the right side of the screen. This patch shifts continuously around the north because of unstable weather patterns in the Arctic. They cause ozone concentrations to fluctuate on a daily basis. Ozone monitoring equipment around the world continues to keep a close watch on the situation. This Canadian instrument is one of the most advanced ozone measuring devices. The seriousness of the situation has rekindled an international movement to save the ozone layer. In Montreal in September 1987, Canada hosted a United Nations conference which drafted a treaty to reduce CFC production around the world.
Les accords de coopération peuvent être assurés que nous examinerons avec le plus grand soin les demandes qui pourraient...
Since then, more stringent measures have been proposed that would speed up the complete elimination of CFCs worldwide. If production of these chemicals is stopped, the ozone layer will one day regain its health, but it will take time. Due to the long life of CFC molecules, ozone depletion is expected to continue for nearly 300 years after we've eliminated these harmful chemicals. In the meantime, we can expect to suffer the consequences of our atmospheric pollution. The increase in ultraviolet radiation reaching the Earth's surface will cause a sharp rise in skin cancer and eye damage, and impair the ability of our immune systems to fight disease. Sunglasses and sunscreen lotions can help to reduce the damage to our bodies by blocking a good portion of the sun's ultraviolet radiation. But other parts of our environment are not as easy to protect. The ultraviolet stress on plant life, including agricultural crops, will result in lower yields, and further strain world food supplies. In the oceans, a major ecological disaster may be in store. Microscopic plants, called phytoplankton, convert sunlight into energy, creating the first link in marine food chains. Increased levels of ultraviolet could affect the ability of phytoplankton to reproduce, and this will have serious repercussions on all life in the oceans. Fewer phytoplankton will ultimately mean fewer fish, and the largest creatures that have ever lived on this planet may eventually cease to exist. All life on this planet owes its continued existence to the sun. But through our own actions, that sun has become an agent of misery that now threatens the health of the very life it sustains. Meteorology in Canada has come a long way in its quest to understand the atmosphere. From those early attempts at forecasting, it has blossomed into a complex science. The sky has become a vast, wild laboratory in which we conduct our explorations. But our studies of the envelope that surrounds our planet have revealed just how delicate it is. We find we're part of a closed system where actions of ours can have terrible consequences. Just as the need for storm warnings gave birth to the Canadian Weather Service, the need for continued study of these new and frightening storms above us must be a driving force in the years ahead.